All right, so in this video, we're going to go over some coordination chemistry nomenclature. I'm not really, big on nomenclature. It's not something I think in chemistry should be stressed too much. Um, if you can draw out a structure, that's good enough for me most of the time. But I just want to show you this so you get a feel for how it works, and so when you're reading the literature and reading various texts, you'll know uh, or be more comfortable with the words you're seeing. So, there's many different ligands. Here are some shown. Some of these, especially the chelators, have their own little abbreviations. Um, but you'll notice that, like for ammonium, it has a slightly different name when it's used as a ligand. So you call it amine. Or this is chloride, right? We're going to call it chlorido. So a lot of these have idos or ados. Carbonate, when it's a ligand, it's called carbonado. Carbon monoxide, carbonyl, that's very common one that you'll see. Fluorido, hydrido, hydroxido, iodido. And then we talked about for ambidentate ligands, the use of this very good nomenclature using kappa. Um, and so that tells you, what is the donor atom in those cases. So on top of that, there are different prefixes that you'll use. So if you have, let's say six ammonia ligands, you'll call it hexaamine, right? And you can see all these other prefixes. Those are pretty intuitive. You'll notice that I've listed some that have more than one prefix. The primary prefix for two is di, tri for three, and tetra for four. But in cases where you might have to use multiple prefixes, or there's another number in the formula, you're going to use bis, tris, or tetrakis, or pentakis, hexakis, etc. And you'll see some examples of those, but it's just to avoid some funny sounding words or having a lot of numbers together. So, for example, if we look at this complex, how would we name it? Well, um, there's six ammonium groups. So if we go to our table for ammonium, we're going to call it amine, and our prefix is going to be hexa. So we're going to call it hexaamine, and then at the end, usually at the very end, this is what the IUPAC recommends, you're going to put the metal name. So it'd be hexaamine cobalt 3 plus. Um, this one is similar, but it's just a 2 plus, so we call it hexaamine cobalt 2. Now, this is actually a coordination compound, not just a complex. So we would call this what? Well, sulfate is a -2 charge. We know that from our general chemistry. And so the complex must be a +2 charge. That means since we have neutral ligands, 6 neutral ligands, cobalt must be +2 as well. So we're going to call it hexaamine cobalt 2, and then just add sulfate, right? Hexaamine cobalt 2 sulfate. What about this one? This one's just a ion, just a complex. And so we have two chlorides and two amines, right? And so what do we call chloride? We call it chlorido. And so we're going to call this tetraamine dichlorido cobalt 3. Now, why didn't I call it dichlorido tetraamine cobalt 3? That's okay. It's not what the IUPAC recommends. They recommend that you put the ligands in alphabetical order. So the A in amine goes before the C in chlorido. Again, you'll see in the academic literature, chemists are pretty lazy with this. It's best to kind of show a structure like this, or even better, right? Draw out a structure so you can see the coordination geometry if you know that. But sometimes it's nice to know what the actual name is. Here's one with an N ligand, which is abbreviation for 1,2-diaminoethane. And so this is a case where you're not going to use tri, you're going to use tris, because you have a number next to it. And so it's just a little bit easier to say tris 1,2 a diamino cobalt 2 versus, sorry, this should be cobalt 3 actually, versus, tri. But that's kind of how that works. Here's one with two metals, and so it has 8 chlorido ligands, chloride ligands, so we'll call it octachlorido-direnate. And why did I give it an 8? Why isn't it not direnium? It's because this is an anion, so it's like sulfate. Usually a lot of the anions we have in chemistry, in general chemistry, have 8s. Same idea here. So if you have anions with metals, you're going to give them 8. So this is octachlorido-direnate 3. Here's another one with an 8. It's an anion, so it's going to be called tetrachlorido. We have 4 chlorides, platinate. 2 is the oxidation state. And bridging ligands have their own sort of nomenclature. We use this mu. And so if you just have mu by itself, that means it's a ligand that's bridging 2 metals. So you can see here, we have a mu amido, okay, and we have a mu hydroxo. This is you can see coordination chemistry doesn't have, it has a lot of variability in the naming. So by our table, we should call this mu amine, but this, website that I got it from calls it mu amido. People are going to know what you mean. Or this says hydroxo. What did our table say? I think hydroxido, right? So again, there's a lot of variability here, which is why I'm not going to necessarily. I'm never going to test you on this going from structure to name. That's kind of not useless. You can use a program. There's various programs out there to generate the names. ChemDraw, for example, certain versions of ChemDraw. More useful is being able, if you see a name, to go from name to structure. So I expect you, if I give you a name, you should be able to draw the structure from that, right? But anyway, so this we could call mu amido or mu amine, mu hydroxido. Again, it's alphabetical order here. Bis, because you have 2 of them, and you have a tetraamine cobalt. Okay, so that's why they use bis here, because you have 2 of these cobalt tetraamine complexes that are then bridged by the ammonia ligand. And it's amido here because it's NH2. Okay, there we go. Not amine because it's NH3. And OH should be hydroxido by our table. But anyway, again, these are small details that aren't important. Really just trivial, right? A name is nothing more than a name. What about this one? This is tris tetraamine. Okay, there we go with amine, because amine here. 1, 2, 3, 4. Okay, 1, 2, 3, 4. 1, 2, 3, 4. There's 3 of them. Okay, 3 cobalts. 1, 2, 3. And then we have mu dihydroxido by our nomenclature, cobalt. You can see there's 2 sets of bridging hydroxide. So, this is kind of what's so cool about coordination chemistry. It can get very complicated, right? And as such, the names kind of get so complicated that they begin to get pretty cumbersome.